All right, we're still looking at systems of linear inequalities. Example 4. Now we are going to write a system of linear inequalities represented by the graph. All right, so you can see that we have a solid line and it's shaded above the line. And you can see that we have a dotted line and it's shaded below the line. So the first thing is maybe to look at the boundary lines, and that's a good way to get started. So let's think about just this line right here first. This is solid. It's a horizontal line. So it goes through y at -2. So we're going to have everything. I started with my inequality symbol. Sorry about that. Let's see. Let's try again. So I'm going to have y, and I'm going to have greater than or equal to. Still struggling to write for some reason. Let's see, try that again. All right, y greater than or equal to, and we said this is our x-axis, -2. So this one doesn't have a slope. So it's simply y greater than or equal to -2. Now, the second one is a dashed line. It goes through the origin, and it's shaded below. So this one's going to be y less than. Not less than or equal to, because it's a dashed line. So just y less than what? So the y-intercept is 0, and it rise 1, run 1, rise 1, run 1. So you can see that the slope is 1, and the y-intercept is 0. So you can write it like that, or you could simply write y greater than or equal to -2, and y less than x. The 1 is assumed, and you don't have to have the 0. So either one of these would be correct. This is the most condensed, simplified way to write it. All right, again, you can pick a point inside the boundary line to see if it is true. Since 0, 0 will not work because it's a dashed line and it's on the boundary line, you could choose 1, 0 or 1, -1. Choose a point somewhere in here would be fine. Let's choose 1, -1. So if we choose 1, -1, that's just checking to make sure that these work. So -1 is -1 greater than or equal to -2. That is true because -1 is closer to 0, so -1 is greater than -2. All right, is -1 less than 1? Yes, that is true as well. So checking to make sure that your inequalities work is always a good thing. All right, example 5, write a system of linear inequalities represented by the graph. All right, so here's our y-axis, here's our x-axis, and we can see this is a vertical line. So this one's going to go through x at 1, 2, 3. So this is going to be x. And we can see that it's everything less than, because 2 is less than 3, 1 is less than 3, and it's shaded in this direction. So this will be less than or equal to. And again, this is just 3 because 2, 3, 4. So x less than or equal to 3 represents this solid line here. And then we have another dashed line. We need to write an equation for this. So if we look, the first thing we can see is that it's going to be above this line. So we're going to have y greater than. It's not greater than or equal to, or it would be solid, so it's just greater than this line. And then we can start with the y-intercept is -1. And then we can use the y-intercept to locate the slope. So you can see another point is right here. So this goes up 2 over 3. So we have a slope of 2/3 and a y-intercept of -1. All right, again, it's good to choose a point. Let's see, this time you can choose 0, 0. So is 0 less than or equal to 3? Yes. Is 0 greater than 0 minus 1. Is 0 greater than negative 1? Yes. So that's easy to check if you choose the origin or 0, 0. All right, last example. Example 6, modeling real life. A company is loading recliners and sofas onto a trailer that has a volume of about 3,800 cubic feet. Each recliner takes up about 40 cubic feet and each sofa takes up about 80 cubic feet. The company wants the shipment to have at least 30 recliners and more than 25 sofas. Write and graph a system that represents the situation. Give one example of the number of recliners and sofas the company can have in the shipment. All right, so the first thing we need to do is notice that we are loading recliners and sofas. Let's define our two variables. Let's say let R equal the number of recliners and let S equal the number of sofas. All right, so it says write and graph a system. All right, so it says we have a trailer that has a volume of 3,800 cubic feet. That means we're going to have less than that or it's not going to fit on the trailer. So we're going to have 3,800 or less cubic feet so that the recliners and sofas fit on the trailer. So it says each recliner takes up about 40 cubic feet. So we can say 40 cubic feet times the number of recliners. Recliners would be R. And then plus each sofa takes up about 80 cubic feet. So 80 times S. So we know that together the recliners and the sofas cubic feet have to be less than or equal to 3,800. Again, that's because that's how much volume is on the trailer. Anything more than that's not going to fit in the trailer. All right, so it says the company wants the shipment to have at least 30 recliners. Okay, recliners are R again. So we need R to be greater than or equal to 30. At least means greater than or equal to 30. And it says more than 25 recliners or sofas. So we're going to have sofas has to be more than, which is just greater than 25. All right, so you can see I have a graph here and it already has just quadrant 1 because you're not going to have negative numbers. You're not going to have a negative number of recliners or sofas. So only quadrant 1 is going to make sense here. So let's go ahead and graph the two easy ones first. Let's graph R greater than or equal to 30. You can see I have number of recliners on the bottom. So that's going to be a vertical line here. And it's going to be a solid line because we can have 30 recliners because it says at least 30 recliners. So we're going to have this and greater than would be in this direction here. Again, this little arrow just points that just to remind us that that's greater than or equal to. All right, let's graph the number of sofas. This one is S is greater than, so more than 25 sofas. This one's going to be a dotted line. And we have number of sofas on the vertical axis, so greater than 25. And that's going to be represented everything above that. And again, this arrow, it's just to let you know that we want above the red line and above the blue line. Okay, just right here kind of lets us know. Did not mean to put an arrow there. Let's see. Just going to color code this so we know. All right, let's use orange for this one. All right, so we have one more to graph. All right, so we can quickly put this in like slope-intercept form if we want to. This is our y-axis, so we can say s is similar to our y. So let's solve for s. So we can do that by quickly subtracting 40r from both sides. So we're going to have 80s is going to be less than or equal to minus 40r plus 3,800. All right, so all I did was take this equation here and subtract 40s. I moved it to the other side because I'm trying to solve for s. All right, I'm going to divide both sides by 80. That means I divide everything by 80. All right, that leaves s less than or equal to negative 40 divided by 80 is going to be negative 1/2 r. And then 3,800 divided by 80 is 47.5. All right, so what this does is kind of put it in slope-intercept form. It gives me a slope and a y-intercept. So I can see that I can graph my y-intercept here at 47.5. I'm going to have a point here. And down 1 over 2. Since these are in blocks of 5, if I go down 1 block over 2 blocks, I'm doing it in multiples of 5, but it's still going to be the same process. So down 1 over 2, down 1 over 2, down 1 over 2. All right, so since this is less than or equal to, we are going to have a solid line here. And this one says less than or equal to. So we're going to have everything below this line here. So what we really want, the number of recliners and sofas is going to have to be greater than the red line, greater than the blue line, and less than this yellow line. So there's a very small window here with the number of recliners that's going to fit. So let's see if we can find an ordered pair, because it does say write and graph the system, which we did, but it also says give one example of the number of sofas, the number of recliners and sofas the company can have in the shipment. So let's try 35, and let's say something right below 30, because it kind of looks like it hits on 30. Let's say 20 or 35 and let's say 28. That would be a point right in here. So we're going to try 35 and 28. Now, how do we know if that is a solution? And because we're talking about recliners and sofas, it has to be a whole number, because you're not going to have half a recliner or half a sofa. So even though we have this whole area shaded, we know that it's going to be whole numbers here in order to make this actually work. All right, so is R, okay? So this would be my R, and this would be my S instead of my X and Y. So is 35 greater than or equal to 30? Yes, it is. So this point works for this system. All right, is S greater than 25? S is 28, so it is greater than 25. And then plug 35 in here and 28 here. And so if we do 40 times 35 plus 80 times 28, we get 3640. 3640 is less than or equal to 3800, so